I'm talking today about the very near future of web standards. And I work for Mozilla. I work as the HTML5 spokesperson. And I have a lot of conversations with lots of companies, with lots of other browser makers, with the press about HTML5 and if it's ready and if we can use it and what the enterprise can do with it and stuff like that. So I think it's important to understand a few things. And normally I point out a lot of things that are broken, but that frustrated me over time. So today I'm going to show you a few things that are actually working right now that you might not be aware of. And some of them you might have seen before, but others you might like, whoa, this is really, I can use that. And yes, you can. We don't have to build things for the 1990s web anymore if we do it the right way. So in general, we live in terribly exciting times. As a web developer, I've never had much more fun than nowadays because the HTML5 hype is over. I remember when Apple went on stage and said ooh, Flash is dead, HTML5 is the solution, and then didn't give us the solutions that we needed. So we actually stood there and had a problem with it. But now we actually start questioning it, and I love questioning things. I love making mistakes because I learn from mistakes because I don't want to do them again because they hurt. So that's what we're doing with the open web and with web standards right now. And there's lots of movement, there's lots of change going on. A lot of people want to be part of the web that never been part of the web, that before that only did closed technologies. And other people who've been on the web for years and years have to change their ways as well. Because nowadays we don't start with doc type HTML. It's we start with build scripts, we start with libraries. A lot of developers that come into the market never coded by hand and don't want to, which to me is a step backwards, but this is just the realities that we have to deal with. There's lots of questions, and I get questions by the press continuously about HTML5, especially when somebody like Zuckerberg says on stage and says something that can be taken out of context, and then oh, but they said HTML5 is dead. What's wrong with it? How can you use it? So this was a post that came out yesterday or 2 days ago. HTML5 for the enterprise, confusion is the biggest barrier. And I agree, when I talk to enterprise people, they all want to approach the web like they approach Java or like they approach .NET. And they want to have a solution, they want to have a tool chain, they want to have a perfect SDK, IDE, and training courses to send their developers to and board them before they actually start developing. And there's good quotes in there, the overwhelming perception I get from customers is utter confusion about what they're doing. If you pick a noun and add a JS or IO, you probably get a library. It's extraordinarily confusing, and that's the biggest problem. And that's what we do as developers now. We try to abstract all the problems out in the library to end all libraries. If you go on GitHub, there's 6,000 to choose from, and you don't know which of those will be maintained in half a year, or if they really do what you want it to do. So we should stop trying to sell pixie dust to enterprise out there and say if you use my library, everything is fine. We lied like that before. It never is fine. The web is a very, very competitive and strange world to live in. So making it easier is good, but relying on things that might break is not a good idea. So a lot of people take shortcuts nowadays. This was the other day I went to Instructables and looked for unicorn poop cookies, as you do. And then they asked me if I want to download the unicorn poop application, because they renamed the application to what you searched for, which can be quite embarrassing, I think. But that's their SEO idea or something like that. And I don't get this. I understand that you love your apps, that you want your app to make money with, but if I did a search on the web or I clicked a link, I want to go to that content. Why did I type in a domain and a URL just to go to download another 30 meg to get the content that should be at the endpoint of that URL? We're breaking the web just to show people things. This conference has an app again as well. I spoke at 42 conferences this year. Do I want to have 42 apps on my phone that I used once? No, I don't. So a lot of people go into this world of apps to say oh, then we have full control over the end user. And if Star Trek taught us anything, humans don't want to be controlled. How many times do we have to say this? If I just want to get some content on the web, I go there, I go away. I always love that when I talk to clients, oh, what if I have a point that links to another website and people go away from my website? What then? It's called the web. That's what we invented links for. And if they had a great experience on your website, they will come back to your website. If they had a bad experience, you should make that fixed. This is what the web is like. People vote with their feet. We cannot just ask them to download whatever we need them to have. Yesterday was another announcement, or not announcement, I knew that for a while, that if you want to do e-commerce in Korea, you have to support Internet Explorer 6 and 7, because in Korea, the security model, this is the irony of it, security is done with ActiveX. So think about these kind of things at times. So is the open web still competitive? We all said, oh, the apps are the cool thing, and the native apps are the amazing thing. And I'm like, yeah, floppy disks were cool too, but not really in a longer scale. The question is, what do you compare? Comparing a native application with a web application is totally and utterly pointless. Because one of them, the native application, is optimized for a certain environment, sometimes forced to be optimized to a certain environment. A web application, by definition, aligns itself to the environment. If I look at it on my MacBook, I should get a different application than when I look at it on my phone. A better interface for the form factor. A more useful interface where I don't download a background image of 6000K just to basically get a form field to log in. These kind of things we don't make right now. We understand the web as like the worst apps, or the browser, the last app to use on your mobile phone. And that's not the case. There's a great paper out right now at developereconomics.com that you can download. How can HTML5 compete with native? And they compare a lot of numbers, and they ask a lot of developers what's going on there. And we're playing on a pitch with holes. I got quoted by another website yesterday about this. 63% of HTML mobile developers go direct to the browser when developing. We work in browsers. We've done that for 10 years. Why should I download an IDE or an SDK and start building with that? The browser is the most popular route to the mobile market. This is what we use as developers. Yet 60% of Android apps cannot be implemented via the mobile browser due to the lack of APIs. And this is because stock browsers are evil and kill kittens. They're the new Internet Explorer 6. If I have an old Android and I cannot download Chrome, I have a piece of hardware that is just not useful to me anymore as a web surfer. Making a browser part of the operating system was always an incredibly stupid idea, but we keep doing it over and over and over again. If I have to buy a 600 euro phone to get a better web experience, then we've gone back in time. The web is out there for everybody, not only for the rich people in the Western world. 37% of Android apps could be implemented using HTML5 via the mobile browser. 37%, a third of the apps only. That's not good enough. 49% via PhoneGap, 63% via Accelerator, and 98% via Firefox OS. Tomorrow I'm going to give a talk about Firefox OS and show you why that is. In short, we built Firefox OS with HTML5 rather than like putting HTML5 into it as the fallback if nobody wants to download your great app. And this is something that annoys me as a developer. And it annoys me mostly because the open web standards that we're working with are open. And they ask you to actually be part of them and you to fix them with us. Not to wait until from the blue sky the perfect HTML5 solution comes and the perfect browser comes, because that's not going to happen. When I started as a web developer in the 90s, browsers were these things somewhere in a world that I could never touch. I just hoped that something was supported in a browser. There were no mailing lists, there were no bug trackers, there were no people from browsers that you meet at conferences that you can shake and ask them to do things for you. Nowadays we have all that. All of that is open. And a great example how something like that works is this font. This font looks awful. It's called Bell Centennial, and it's just totally weird. What are these missing bits here? Why would you not make this straight and make this weird curve that just looks terrible? I mean, I'm not a typographer, but even I can see that something's going wrong there. Well, the font was written for phone books, for the Bell phone books, the Yellow Pages. So Yellow Pages are printed on very, very bad paper. So the ink bleeds out, much like a tattoo bleeds out over a few years. So this is what it looks like on a screen, which is awful. This is what it looks like on paper, which makes much more sense. Because if you see it printed in the magazine, it becomes readable. Somebody defined that font for use in a certain environment that they cannot control, which in this case is terrible paper. We define web standards for an environment that we cannot control, which is people in internet cafes, people at home, people on connections in America, and not like broadband connections like in Sweden. we don't control the end user's experience, so we have to build our things flexible with gaps in them to be filled. And these gaps is why we need developers to look at web standards and complain, and use them and try them out and find mistakes. Don't listen to anybody who goes on stage and says, that is a best practice because I just invented it. Best practices are found in implementations and verified by several people to become a best practice. Not somebody saying, we should do this, this is a best practice. This is not a best practice, this is a proposal. And proposals become best practices by application. So this is how we should use web technology. Try this stuff out, find the gaps, complain, get the gaps filled. And sometimes the gaps are by design. Sometimes CSS doesn't do things that Less or Sass does because it would be a computation nightmare for the browser, for example. Sometimes we can't get the things as developers we want to have because it would be a security problem for end users. WebSockets was a good idea. WebSockets, the first standard proposal or the first specification had a massive security hole in it. So Firefox turned it off until we fixed it. It took us 3 months, then we fixed it, re-implemented it, and turned it on again. End users should not have their computers hacked because we need new cool tool technology. It should have a good browsing experience. So let's go through a few technologies that you might have used or you thought you might have used, but things you haven't done before with them. Some of that might be old school for you, I hope not. CSS. CSS, basically the things that every JavaScript developer hates because the logic is just completely different. The syntax is weird. Like if somebody is exclamation mark important, to me it means it's not important. But in CSS it is important, so it's kind of odd. We have transforms. Stop using position absolute and top and left. Because if you do, then you actually slow down the browser. This is not hardware accelerated. This doesn't run on the video chip, of which we have really cool ones in these. And this is what it looks like. A skew transform, which I never understood what makes any sense, looks like that, and you can skew it to something else. You can skew it to 20. You can scale the thing to like 3 or 4 to make it bigger. And all of that works across browsers nowadays without a prefix, as you can see here. And then the good thing about it is when you position with top and left, all you can do is positioning. With transform, you can do whatever. So I can now rotate this thing as well. So I can say rotate 30 degrees, and all of a sudden I rotated it. So I take the skewing away, and I have a rotating thing here. I can rotate it 90 degrees and put it to the side of the screen if I wanted to as well. So all of these things are possible in browsers nowadays, and that's the 2D one. The 3D transforms, which is a better transformer, so it's Optimus Prime, does the whole thing in 3D. So I can rotate this here now to like 60 degrees. I can rotate it in Z20, and I can rotate it in Y another 20 degrees. And then you can see that it actually goes into the space, and you can do like full Star Wars scrollers and all kind of stuff in it. Not necessarily that useful, but beautiful for things like animations and nice things. Also, when you, on iOS, on older iOS, if you want to have hardware acceleration, you have to do a 3D transform, not a 2D transform, because Apple works in the dark, and we don't know why that is, but sometimes you have to coax it into doing hardware acceleration. Transitions are beautiful. If you don't want, if you just define one style and another style, and a transition between the two, you don't have to do any calculations whatsoever. So this one now goes from red to white really smoothly. I can change this to blue here, and then it goes from red to blue really smoothly. I can actually change the width, I can change the height. I don't need to know what the designer wants to have the two different states to have. All I put is a transition on it, and I know it's going to be smooth. And that's a beautiful thing to have. And, okay, animations. CSS animations, like by this now, like you would normally do. Now unprefixed as well, so stop using that WebKit keyframes. I think by now Chrome has caught up as well. But this one is, again, like completely changeable. So I can scale this now to 4 when I animate it, or I can scale it back to 2 again. I can translate it to like 200% to get it off the screen rather than just 100%. So now it swooshes out and it swooshes back in. I can make it faster, so I can do 1 second. And all of this is hardware accelerated. All of this is happening in the browser for you, rather than you doing the animation and doing the calculation and hoping that everything works. If you do JavaScript animations, don't use set timeout. Another big problem, because set timeout hopes that the animation happens in the right time that you say the timeout, but the browser is busy painting the screen. Request animation frame is the replacement for set timeout that makes sure that the browser actually does the animation while it's painting the screen rather than you working against the browser. And it also means if the tab is not active, your animation doesn't run and doesn't suck people's battery and doesn't make people unhappy and doesn't kill kittens. So when something is not active, it shouldn't do an animation. What's the point of that? Why should I burn cycles on my computer if nobody can see it? So Flexbox, that's the coolest thing ever. And that was a pain to implement in the browser because it's really hard to do. But this is something that every Java developer tells you that we need tables for because CSS cannot do it. So Flexbox allows you to put flexible boxes, hence the name, into a display. So I can say start here or I can say end, then it moves the boxes to the end. If I don't give it anything, then it makes the boxes as high as the box containing them. That was a pain to do in CSS, now we have it. So you can actually do that in the end here as well, or in the center. So you can shift the thing around in the parent element any way that you want to. Now, this is now as big as the content of these elements. If I set a flex of 1, then it starts actually using up the space and resizing the things accordingly. So now each of them uses up the same space without me setting 33% and trying to calculate what 100% minus divided by 3 minus padding minus margin minus border is. Browser does that for me. You see this has a border radius here around it, for example. All the calculation happens for it. Now, if I want to actually do a MOSFlex 2 here for the second one, it uses up more space. And I can actually make a navigation that is independent of the amount of elements that are out there. And again, I can shift this now to the end or make it just scale to the whole full box as well. The other thing is that it's independent of the source order. So if I want to have 2 at the first one here, then I move that to 0 and the 2 would move around. I can also move it to 2 and it moves it to the end of it because it starts counting at 1. This is once again, as a developer, I start counting at 0, not at 1. But as a human, I start counting at 1. That's why they put it in CSS as 1. Flexbox gives you so many solutions to problems that you have. There's a great GitHub repository called Solved by Flexbox, which shows you like vertical centering, sticky footer, simpler grids, also on and forth. And we needed that. Chrome was the first one to implement it in Safari. Mozilla didn't implement it because it's such a pain to do, because you can think of a renderer that has to realize that the order might not be the one that it comes in HTML, are already going through the HTML tree. But then Sencha created Fastbook, which was this demo showing that HTML5 can be as fast as native applications with Facebook, and they needed Flexbook, so we had a real use case. We had somebody who had insight why they need it, how they need it. A lot of technology does not get implemented in browsers because technology makers are lazy developers like we are as well. So if nobody requests the thing, why should I put money and energy onto it? So we need use cases. We need how things break if things are not supported. Canvas is a painting API. That's the idea of it. You can plot things on the screen, you can draw rectangles, you can copy images, you can rotate images. But it's also, to me, the more interesting bit about Canvas is it's a pixel access to an image. Every image turns into an array of pixels, and I can shift them around, I can play with them, I can do things with them. And that's what I did on Commodore 64 and Amiga, so we're going back to that. This is pretty cool, that every image becomes something you can manipulate in the browser. So for example, this was this website that had this animated GIF of the American states, and it was far too fast to actually realize what's going on there. So what do I do? Do I download it and open it in Photoshop? No, there's a bookmarklet that would take any animated GIF, turns it into its frames, and then gives you a navigation like through a video to go through an animated GIF frame by frame. So this one now down there has these buttons, and I can now stop the animation and go through it frame by frame. So an animated GIF is not this black box thing that goes into the page. I can read every single frame of it and control it with JavaScript. And how cool is that, that nothing in the browser is locked from me anymore? Another thing I did with Canvas is irregular shapes. So you can see the mouse only triggers the rollover when it goes on the image rather than like on the transparent pixels of it. That was impossible with CSS. That was impossible unless you just put like rectangles on it and an image map, and it was really hard to maintain. With this, I just put a GIF or a PNG in there, and if it has a transparent pixel, it doesn't do the rollover. If it has a non-transparent pixel, it does the rollover. That's the kind of stuff that is just one line of JavaScript, more or less, nowadays. Image masking, something we had in Flash for a while, which the browsers still don't do. I mean, there are CSS proposals by Adobe doing it, but with a canvas, you can easily do that. So these are the 3 images down there. These are the PNGs. And this is the result in the browser if you just put this JavaScript in there. Again, by reading out the image, putting it on top of the other image with an alpha channel blending, and that's all you needed to do. So look at these technologies and see how else you can use them rather than the obvious use case. That's what fun as a developer is about. WebRTC is going to be the big thing in the future. It's first and foremost, it's just audio chat and video chat over the browser, or accessing the camera and doing things with it. But it's also data connectivity and peer-to-peer connectivity. So you can scale multiplayer games to thousands of players because you don't have a server in between that burns up with all the 1,000 players needing to go there. You negotiate through a server, and then the 2 computers talk to each other, and you don't have to be part of that anymore. You could write a BitTorrent client in the browser with this. Actually, I've sat next to somebody on a plane, they're working on a VNC server using WebRTC, which is like you VNC into another computer in JavaScript. That's mental, but it works already. So this is another example how you can access and manipulate GIFs. This is called Face to GIF. So I press the button, it accesses my camera. This is totally possible nowadays. And then I can start recording the camera. So I press the button and it starts recording the video that comes from my browser. Once I'm happy with it, I can actually make GIF. It's compiling, so that's using a web worker in the background, so it doesn't even slow down my interface. And then I have an animated GIF of the video that I just had. No software to download, no plugin needed. This is working in the browser right now. I think this is pretty cool. This kind of stuff we didn't have in the past, and nowadays we can do it. Google Hangouts uses WebRTC, and they're incredible. The other day I was supposed to go to Korea, then my credit card got stolen, so I couldn't fly. So I gave my talk over Google Hangouts, which is a bit depressing sitting at home in front of your computer. But at the same time, I still gave my talk, and it worked, and people asked me questions. We have a system called WebRTC Together.js. Together.js is a JavaScript you can pop into your page by the Mozilla Foundation that gives you collaboration in the browser. So you have multiple cursors for multiple users. You have audio chat and you have chat. So what does that look like? Whoops. This is what it looks like. You put a script in there, you put a button in there saying start Together.js, and then you got text chat, user focus, and audio chat. And that way, for example, you can build something together. So this is not Adium or this is not Skype. This is now in the browser with them just putting the little JavaScript in there. So you've got this chat window, and these are the different users with different cursors, with their name next to them. So they can actually code something together, and it works out rather fine. The other one is here is using JS Fiddle. JS Fiddle, Mozilla Thimble, but JS Fiddle does this as well now. There's a collaboration button in JS Fiddle where you can actually code together, and you can't hear it right now because I turned off the sound, but these are the people chatting with each other over audio chat while they're coding together, and they're fixing things together. So for like customer service, for teaching people how to do some code, that's a wonderful thing. You don't have to send them videos back and forth. Collaborative coding is a very, very cool thing. And this one just shows how to use some canvas animation here. So Together.js, use that and play with it. Right now it's in beta, but it will be out there rather quickly. Now, hardware access is something everybody complains about. We don't have access to the hardware in HTML5, in Android, in iOS, and in others. In Firefox OS, you have complete access. And we're working on lots and lots of open standards to make that work for you. These are not Firefox only. These are for all browsers out there. So, for example, the vibration API that I'm going to talk about tomorrow as well is now implemented in Chrome as well. And I'm like, yes, we don't want things only in Firefox. We want them for all the browsers out there. So this is, for example, the battery API, and this works in Firefox right now. I can just put a meter element in my HTML. I can say, I can get it with a document query selector. I read out navigator battery, And then on level change, I set the level. So this one now displays my battery here. It displays it up on the screen as well, so it's rather pointless. But what about your application realizes that the laptop is already 20% down and then turns off some animations? Or tells the user, hey, your battery is rather low, shall I actually save things for you every 50 milliseconds rather than you losing your data? You can write clever animations that way. This is really cool. It's the device light at event listener just on the window. And that one reads the light around my computer or around my mobile phone. So if I put my finger on the sensor here, it actually goes down to 0 if I do it right. And it can go up to 50,000 depending how bright it is around my computer. And this is always on. My camera is not on right now. My battery is not being sucked dry. This is already on because it actually powers the backlit keyboard on MacBooks. So that's why this sensor is always available to you. So as a developer getting random numbers from 0 to 20,000, I can do cool animations with that. So that's something to read out and play with. Browsers are not these magical things that JavaScript ninjas do in their back garden that I don't have access to. All of the information is available to you, what browsers are going to do next, what browsers are doing right now, and you actually have access to how the browser does things. With HTML5, we don't have anything in the document anymore that is basically unknown. Everything is just an element. You can style it, you can do anything with it. But if you put a video element in the page, there's this play button, and there's this volume control, and there's this scrubber. What is this? Is this Magic Pixie Dust? Is it Java? Is it Flash? No, it's HTML. And this is what we call the shadow DOM. So in Chrome right now, and in DevTools, in Firefox soon as well, you can actually see the HTML that gets generated to make this up. You can actually see what the browser did to create a video player, which teaches you a lot to write your own video player if you wanted to, for example. But it also means that you could overwrite these styles or inherit from these styles. So this means with Shadow DOM and web components, we can build widgets that are part of the browser rendering and not work against the browser rendering. Right now we do a lot of JavaScript, a lot of CSS that we hope gets fastly displayed by the browser or doesn't interfere with its normal rendering. With web components we become part of it. So the browser is not doing things against us anymore but with us. So you can create your own elements and get them rendered by the browser. These elements are then independent of the CSS of the page as well, because that's another big problem. We write a widget, we put it in a page, and then we put 5,000 importance and 12 IDs on it to make sure that the main style from the document doesn't bleed into them. With widgets, with web components, we don't have that problem because we can tell them not to inherit any style from the main document. There's a site called customelements.io, which gives you lots of these buttons and video players and stuff what people build already. And this is gonna be the next generation for like tooling as well. For Adobe are very much into that, Google is very much into that, Mozilla is very much into that. Microsoft are looking at what we're doing and are interested. Mozilla Brick is a little library that allows you to do, for example, a flipbox just by writing xflipbox and have a parameter called flipped or not. And you have a JavaScript API into the flipbox element as well. So maintainers just need to change the text in there. They don't need to know how that thing works. They don't need to know how it's styled because you can lock down the styling of it or you can make it writable as well. Lots of jQuery widgets are really, really badly written in terms of the API. You cannot override styles or they're hardwired. And in this case, you have full control or you can lock out full control. All of these things are needed for apps. And apps are a big thing, of course. And we do a lot of stuff with apps. And I'm going to talk more about that in Firefox OS. Because what we did is a packaging format that allows you to install applications from the web and try them before you buy them. So instead of downloading the 50 meg for the app, you can try it out in the browser. If you like it, then download it. We decoupled the whole concept of app markets into the web again. But what if you don't want to write HTML5? What are you like, it's all good, but I don't want to. And it makes total sense. I mean, like we talk to a lot of game developers, game development companies, like, hey, you got to learn JavaScript now. And they're like, I did C++ for 20 years. What are you talking about? I'm not going to learn JavaScript because it's a terrible language to me. I like it, but other people that come from an OO background don't like it. This is the Unreal 3D engine running inside the browser. So we work with Epic Games, and we have a system called Emscripten and SMJS. SMJS is a precompiled subset of JavaScript, so it does all the memory management before it actually gets executed. And with Emscripten, I can turn bytecode from C++ or Java, LLVM bytecode, into JavaScript. So they didn't write any JavaScript at all to port their engine, but you could actually port any Unreal 3 game to the browser right now. And that's running on a MacBook Air that you see there. Pure web technology, no plugins. And this is actually interesting because I want everybody to go to the web. I don't want anybody to have to unlearn what they learned before or embrace JavaScript when they don't like embracing it. So having something like this to turn C++ into JavaScript is a wonderful, wonderful, wonderful thing. All the demos you see of that, sadly enough, are on desktop only. So that's the big issue that we have right now, because that will be powerful for the mobile web as well, like turning a Java game into bytecode and then putting it into the browser itself would be a great thing to have. So this works with WebRTC as well, with multi-channel and like lots of users, so it doesn't slow down the computer and it doesn't slow down the rendering, most importantly. The problem, as I said, all of that originally was only on the desktop and you needed to have a fast browser and yeah, the right browser, so to say, in some cases. In this case, that works on Chrome. I think it works on Internet Explorer now as well. But what we needed was this. And this is a Nexus 4 running the Where's My Water game, which I just downloaded for my Android as well and spent far too many hours on the toilet playing with it. But you see this performance. This is all physics. This is all real-time physics, not like an animation that came before. This is fluently in 60 to 80 frames per second, and it really works out. And in Android you can do that, in iOS you can do that. When you write it in JavaScript, in HTML5 you can do it as well. But this is not an Android phone. This is a rooted Android phone, and this runs inside Firefox. So we used Emscripten and SMJS to take the game from Disney Interactive and just convert it into JavaScript. And this is going to be the next big thing. The GDC is coming, the Game Developer Conference, so we're going to show some more engines and stuff there. So you will be able to turn any of your Java into HTML with that much effort, rather than with having to write it from scratch again. And I was amazed when I saw that and played with it, because I didn't think that performance was possible, but it is possible inside the browser. And again, as this is now JavaScript and WebGL, this becomes hackable. Not hackable as in like stealing it, but it becomes that you can put things in it. We're at the Mozilla Summit we just had, we saw the 3D engine that you saw, and somebody had inside a screen, like you went through a building and had one of these screens there, like the one here, and inside that one we had Doom running in JavaScript. So in a 3D game, we had another game. On the other panel, we had a live Twitter chat where you can type in and show people that it is live web code. Everything becomes Legos. Everything becomes buildable and rearrangeable. So in summary, the web is here to stay. Every 2 years or so, somebody comes up and says the web is dead, and everybody should do Flash, or Java server faces, or Oracle portlets, or whatever we used in the past, like Java applets. Oh yeah, they were awesome. They were wonderful. Like Lake applet and these kind of things. Really useful stuff. And it's gorgeous. The web is so cool. I mean, you saw the sensor stuff. This is available to you. You saw Flexbox, that you can shift things around on the screen without having to calculate it in your head or do a pre-processor calculating it for you. There are no dark unknowns. We all play in the open. Nothing in the browser cannot be actually accessed and cannot be manipulated in a secure manner, of course. A lot of it is locked down because of security issues, that you, for example, cannot read an image from another server and then access the pixels, because that would allow you to insert malware as well. Malware is going to come. We work with bytecode here. Sooner or later, there will be somebody who finds nice exploits of local storage or of funds. This is already happening. But as it is open, we know where it happens and we can patch it immediately. A lot of software seems secure, but it's just because we can't look at it. Like when you look at the source code, like, really guys, this is what you have been doing? And that's why a lot of stuff doesn't get open source, because people just don't want to see what they've been doing. I know for a fact that one browser has a few CSS bugs that are not getting fixed because it would break iTunes. Really? How about fixing that one instead? We need to break things. We need you to break things. Please try out things and find mistakes. File bugs. Don't talk to me on Twitter about this. File bugs. Every browser maker has a bug tracker. And this is where the developers are that are working on browsers, and they can fix it. So play with it, break it, make it harder for us. And luck favors the bold. Go play. Nothing on the web nowadays is locked down to you. You can play with this stuff. Any website, my slides here, you say an inspect element, you actually start, actually I don't like your in summary, go on that one, say inspect this one, rename it to enough already, and you changed it. And this is the cool thing. This is why I loved the web the first time I started with it. I'm like, whoa, I can change this quickly. I don't have to pre-compile it. I don't have to wait for my boss to tell these kind of things. You have these wonderful things in developer tools. I mean, for example, this one here gives you a 3D view of what's going on the page, how deep your DOM is. Which, of course, in my slides here is not that exciting. But if you go, for example, to Facebook, and you look at their DOM and you see what they're doing, so hopefully that's going to load. Well, wireless. Why do you hate me? Not to fret, we can use Twitter. So I can do an inspect element here and take this and then see how deep is Twitter. Much deeper. But I can see what they're doing and I can play with it and I can find out from code what people have been wanting to do and how they did it. So that's a pretty good experience. So don't be afraid to try things out. Don't be afraid to complain about things because we want you to. We want you to help us out, and we want you to find things. And that's all I had. So thanks very much.